Good afternoon, everyone. This is Patricia Shampton with Texas Exes, and Happy New Year, and welcome to our first lunchtime lecture of 2026. We're so glad you could join us this year, and we're welcoming everyone today. But before we begin, we'd like to thank today's lunchtime lecture sponsor, UT Extended Campus, for their very generous support. And we're also super grateful to everyone who chose to donate when registering. Your contributions help us to continue to engage alumni and students across the globe. So thank you very much for that as well. Today's very special guest is Dr. Victor Sampson. He is an associate professor of STEM education at the College of Education at the University of Texas at Austin, and a nationally recognized scholar focused on how students learn science and engineering through practices like argumentation, explanation, and modeling. His work bridges research and classroom practices, helping educators design meaningful and equitable STEM integrated learning experiences for all students. His innovative teaching approaches have been adopted by K-12 classrooms and are supported by a range of organizations, including the National Science Foundation. Please join me in welcoming Dr. Victor Sampson.
Thank you so much. And I'm so glad to be here and be able to kick off 2026 with you all like this. Today, what I wanted to talk a little bit about with you all is, not surprising, STEM education, but STEM education that matters. So we'll go ahead and get started with this. Um, we love our acronyms in academia and as well as education. So I always try to make sure I define everything before we get started. So when I'm talking about STEM education, really that's just a shorthand for talking about the fields of science, technology, which is really computer science, engineering, and mathematics. Okay? So when I hear say STEM, that's kind of what I'm talking about. Now, to kind of kick things off is thinking about all the reasons why STEM is such a focus in the United States, right? So people give lots and lots of different reasons in terms of making STEM or STEM created careers a priority in the United States. So the most common one is really has to do with innovation, right? So in this country, we really think about how these fields really drive innovation wise. And we then can start thinking about how we stack up to other countries. There's different metrics. This is the Global Innovation Index, and it kind of talks about how over time different countries are moving around from being the most innovative to not so much and moving up and down. So we should think about how STEM and STEM related careers end up helping to drive our standing in terms of an innovative country. The other big part of it is really having to do with the economy. And by some estimates, we can think about STEM supporting about 69% of the US GDP. About 2 out of 3 workers are involved in STEM or a STEM related career in some way, which equals about 2.3 trillion in annual federal tax revenue, right? So a lot of money ends up being pushed into our economy through STEM and STEM related careers. And what we're seeing in trend wise is that lots of this occupation, the need for folks that are in STEM or STEM related careers is growing, and it's growing faster than other non-STEM occupations. So there's just lots more jobs to be had as the fields grow, as the need continues to go in the United States, right? So, given that kind of background, the importance of STEM, what we really do start thinking about is, in terms of the education side, is we need more people who are able to do those jobs. So you will find all sorts of news reports, articles, news in the popular meeting talking about how do we bridge the STEM workforce tomorrow? How do we better prepare them? Um, and what we do is we start thinking about, okay, what's the pathway that we can get people into these kinds of careers? And what we end up looking at is what their educational attainment is. So studies like from the Pew Research Center here talks about 3 in 10 workers with STEM jobs have a postgraduate degree, right? So if you look at this, either if you're STEM employed, in a current field, you've either got a bachelor's degree or a postgrad degree, sometimes both in those. But that's quite a few going through the STEM, coming through STEM education. And the Census Bureau actually puts up a lot of information in terms of how degrees end up going into jobs. So if you look at this graphic here, you can see on the left are three kinds of buckets for kinds of degrees. There's the STEM, which would be a science like biology or chemistry, or an engineering degree of some kind, or one in computer science. Then there's the STEM related ones that would be, you could call that education, and come a lot of other things that focus on STEM, and then the non-STEM degrees. And you kind of see how those break down about the number of people in those different degree getting those different degrees. And then we look at what kind of jobs they get. So if you look at this is the pipeline that we're typically most concerned with. Excuse me. STEM degree to STEM jobs or STEM related careers. So over the last 2 decades, I'd say, is there's been a very consistent push to get more people to graduate with a STEM degree. And you'll see, once again, you'll see advertisements about this, news articles, documentaries, all talking about how important it is to strengthen STEM education to remain globally competitive. How do we get our workforce ready to take on these STEM jobs of tomorrow? And so we start thinking about, well, how do we get them into the pipeline? So what traditionally has been going on is we start thinking about how do we entice them to start a major in STEM. And usually we do that by talking about higher salaries or the potential for higher salaries if once you get your degree. And you'll see these kind of breakdowns all the time. So on the left, you can see the Pew Research Center looked at kind of the average salaries of folks that are all employed or STEM jobs or non-STEM jobs. So if you're looking at if you get a STEM college degree, all employed, counting everything, it's about $81,000 a year on average. But if you're in a STEM job, that jumps up to $87,000. So going into these STEM jobs after a STEM degree ends up making more money. You can also do these kinds of practices of where we start seeing salary trajectories, like not even your entering job, but as you stay in these fields, there's more potential for earning more over time, right? So we try to get these messages out to folks to say, hey, this is a good thing for your future. The other big push has been to offer more STEM courses in the K-12 space. So, for example, probably the biggest push in recent years has been around computer science. And you can see here this graphic talks about how the change in computer science courses have changed across schools, K through 12 schools in the United States. In 2017-18, only about 35% of high schools in the United States offered some kind of computer science course. In 23-24, that jumped to 60%, right? So more than half of all high schools are offering these courses in computer science to help get kids better prepared to take on a major or go into a earn a STEM degree. And then what we also then is legislatively, through the legislature and through policy and through other laws, we start making requirements so they start taking these courses. So once we have them offered, make it so it's part of their graduation required to get more kids to try these out. So that's kind of been the big push. So what I get very interested in is thinking about what do these policies and what are these pushes actually end up doing, right? And so there's some important questions we should be asking about in terms of these pushes. And the first one, has this led to more high school students enrolled in STEM courses? So by offering more and changing requirements, do we get more students in STEM courses? I think Texas is a very interesting state to look at. We do a good job of tracking course taking and enrollment. So Dr. Michael Martyr, who also works here at the UT Austin, tracks all of this stuff and then shares it. And here's a analysis that he put together. So you can kind of see on the left here, you've got the percentage of graduates that ever took kind of the classic sequence of geometry, chemistry, and biology, along with algebra and algebra 2. So between 2009 and 2023, pretty much everybody takes those classes. Now, the ones that are more optional, you can see more of a change, right? So these are things like physics or computer science or calculus. And the most interesting things is looking at this comparison of what's been required for a long time and then what has changed and how that's gotten enrollment different. So if you start looking at, for example, for CS with the big push of offering more classes and changing graduate requirements, we get much more enrollment going on, right? So where it was hovering around 3% of all the students, you're getting over 10%, right? Calculus, another optional class. We've got less of a change in that one, some little dips. And then physics and pre-cal actually have an interesting kind of spike around 2011 and then starting to trail off again toward 2023. Now, the question becomes, well, what led to the spike and why is it trailing off now? So, policy-wise, we can see things like the 4x4 course requirement in Texas, where you have to take 4 years of science and 4 years of math. When that began in 2011, all of a sudden we got a huge spike in a fourth year course, which was physics, right? So many more students taking physics. That ended then in 2019, and then all of a sudden we start see a substantial jump. We still see the same amount of students taking the other three requirements: algebra, chemistry, biology, geometry. That stays pretty much constant all the way through, with over 90% of students taking those classes, with the exception of algebra. But you really see this spike when you've got policy that dictates requirements for students taking courses. Next question becomes, okay, how does this push then lead to more people graduating with STEM degrees? So if we've got more students taking STEM courses to better prepare them, so once they get to college, how does that lead, has that led to more people graduating with a STEM degrees if we're better preparing them? And the answer to that question, in short, it has led to more people getting STEM degrees. So this is the a graph that's showing the shares of bachelor degrees awarded in select fields, and kind of hard to read. So the most important thing is to look right here. This is your engineering, your natural sciences, and your health and medical sciences. And you can see with the push of more students taking more courses in high school, we also have more students actually pursuing STEM degrees and graduating with them over those periods of time. So you get to see this uptick in that. All good. Now, last piece is, okay, we've prepared. We've got them into the degrees. Now, the big question is, does this lead to more people who are actually employed in STEM or a STEM related job? And if we start looking at the percent of the overall US population, we're seeing a tick up in the number of individuals that are employed in a science or engineering occupation. So if you look at from 1960 to 2019, where we had started on this push around 2010 or 2000, you're starting to see a slow but significant uptick in the number of people that are employed in these occupations. So they're getting degrees and going into these fields at greater numbers. But there's a big caveat to this, and this is really what I want to focus on and talk about today, is that although we have overall more people going into STEM careers and more people getting degrees because more people are entering that, we're having a retention problem, a severe one. And by some estimates, only about 28% of STEM grad students actually who finish that actually go in and get a career in STEM. So there's something happening during their degree that is getting them to say, this is not for me, even though we've got them there and prepared them to enter a STEM career. So when you look back at this graphic that I showed you before, of looking at the pathway between degree and job, most people focus on this part. Okay, we get more people into the STEM degrees, that ends up with more people into the STEM jobs. But what I think we really need to focus more on in terms of education is this pathway. Why do we have so many people that are in STEM degrees moving out? Why are they leaving and going into non-STEM jobs at such a high rate? Another way to look at that is looking at how many of those jobs actually are non-STEM related. So if you look at STEM majors and the kinds of jobs that they have here, this graph's a little hard to read, so I'm going to highlight a few things here. So this is from 2005. These here represent the folks that went into a STEM related field or a pure STEM occupation, right? So you're looking at those numbers here, which ends up being dwarfed by the number who got a STEM major, like a degree in biology or a degree in chemistry or engineering, and then went into non-STEM occupations. Huge number of people are choosing not to go into that pathway, which is odds, especially since we talk about that's the most growth, there's the most potential for jobs. It doesn't seem that they're not getting jobs. It's just something that they are wanting to not go into or actively avoiding. So the question I think we need to really ask ourselves is, why is this happening? Okay. So we start studying and looking at what's happening in our majors, and you start getting some very interesting information coming out from studies that start polling students after what they've left the field. And so these are not even the students who graduate and stayed in it, but you'll hear 90% of students who left STEM majors mention the poor quality of the teaching or the introductory college courses. So by the time they get into those first courses, they're like, this is not for me. I want to move out of this. I'm going to go to something else. So we're losing majors right there in the pipeline as well. We also hear students talking about these courses being weed out courses that focus only on lecture. And then we get this constant general dissatisfaction with the style of teaching through lecture, which is kind of funny because this is what I'm doing today. But this idea that the classroom environment lacks structure, it's very impersonal. People are just not enjoying attending these kinds of classes, so they choose to leave. We're also not doing much better in K-12. So here's an interesting survey. So of all the AC test takers in 2024, were asked about their STEM courses they took in high school. So these are all folks that were planning on going into STEM in there, were taking the ACT, took a lot of STEM classes. And of these a little over 3,500 students, about 71% of them said they liked their STEM classes, right? But 29% of them said they didn't, even though they're still in there. And then you break that out for the folks that said they didn't, that disliked, you start talking about, well, why that is. And you start seeing the same trend: bad teaching, lack of course variety, which means being taught in the same way. Courses are too difficult, they're too rushed, they're not applicable to the real world, right? All common reasons for disliking these kinds of STEM courses. Also, it has to do with interests, I think, as well. This is an interesting study. So this is looking at students in high school were asked these kinds of questions. So 2,800 students were asked, high school student, about STEM, and they're asking, is it important to your future? And a vast majority, 64%, agreeing that it's important for their future is huge. However, when you ask them about, well, how's your STEM courses? Like, are you enjoying those? Only 51% of all of those students say that they're interesting. And if you break that down and you ask girls specifically, you get that down to 45%, right? So people are taking these courses because they feel that there's a need, but their interest in it is really tanking as they're in there. So what does this all mean for STEM education that matters? And I think a lot of this can be boiled down to this very simple characteristic of people. And if you think about people as a rule, they seek out things they enjoy and feel good about, and they actively avoid things that make them feel uneasy, anxious, or unwelcome. So we really need to think about how STEM is taught in K through 16 spaces. So my argument is that we need to focus less on creating new incentives or requirements. People have the message that STEM is a valuable career pathway. There's money to be made with good salaries in that. But the problem is we need to start focusing on their learning experiences that they're having in there. So they either want to continue in a major and not drop out of it, or if they're too far along in their major and they realize they don't like it, go into another field, right? And I would argue to do that, we've got to start really thinking about how to make learning experiences more meaningful, coherent, and equitable for students. So when we start defining those and digging in on that, when I talk about meaningful, it's not knowing the objective of the lesson. So lots of kids in our K-12 space will be told, this is what you're going to be learning today. And if you think back to school yourself, could you imagine sitting here in a classroom and this is what you're presented with at the beginning of the day? Today, I'm going to recognize the name of elements and its chemical symbols. Okay, why do I need to know this? You get a lot of this, why am I doing this? It's also not meaningful, also doesn't come from saying but so when you need to know this, it's, well, for the quiz or the test or the state test or to graduate from high school or for college, right? It's pushing everything down further and further away and not asking kids to really start thinking about what is it meaningful now, right? Whether you're in middle school or high school or college, what is it now that's meaningful about this? And what I would argue is we need to start really thinking about how to make our learning experiences more satisfying in turn of focusing on kids' curiosity and focusing on topics that are interesting or relevant and important to them, right? So not so much like the list of facts that we have to memorize to get you better prepared, but showing kids that these topics are relevant to what you're doing. They're important in your everyday life. They're interesting to you, so you want to spend time studying them. The second part is that it's coherent. So often when we think of coherent, we say, okay, a textbook is laid out with these pieces of information. We're going to follow those chapters. Once again, students in these classes who are new to these fields don't see this as a meaningful progression, right? Of like, why do I start with the chemistry of life, then go to the cell, and then genetics? Why do I have to go in that order? Why is it this way? Because the author decided it. There's usually not an answer to those pieces. Math is much the same way of breaking down complex ideas into small pieces, and then they're sequenced, and then you have sequences of lessons that build toward the bigger topic, but you never understand why you need to know the bigger topic in the first place, right? So we'll talk about all of these things that you're building into you go to this lesson and this idea and this idea and this idea, all built from somebody outside of the student's perspective. But the student themselves is, why am I learning about this? I have no idea. And it becomes just a long list of skills to master or terms to memorize. So what I would argue to make it more coherent for students, it needs to follow their questions. So back to where things make it interesting and relevant, people want to learn things when they have questions about them. So when they see something that's unfamiliar or unexpected, or they have a need to learn about something, they're going to automatically ask questions. And those questions make things coherent from their perspective because I need to know this now. I need to know the next thing after I know this thing, but it's being driven by the students' perspectives. And then finally, we need to think about how do we make our learning experiences more equitable for students. So as you notice, when students are reporting about their degrees and courses, they talk about the bad teaching or an unwelcome environment. These kinds of things are only providing the existing structures of lots of courses, and what's done in those is only providing some students with a fair opportunity to learn. We need to start thinking about all the other students that are leaving either the majors, the fields, or choosing not to opt in a career. Why is that? Are they having a fair opportunity? So one of the biggest things you can do to make sure that students have a fair opportunity to learn is really think about, and when you're in a classroom learning experience, making sure that every student feels like their ideas and participation are valued. They're not just another person in there, or you can sit through a class and not engage with anybody or talk about anything and just be on your phone. It's how do you know that my participation is valued? People are looking forward for me and being there. My ideas are important, right? That's why people want to end up sticking with those. And it also makes it possible for these folks, as they see their ideas and participation value, they start to see themselves as a knower and doer of a STEM discipline, that they can use their own ideas and their perspectives along with all of the ideas from the practices, all of the ideas from the fields and the practices from the different fields to help make the world a better place because we're focusing on things that are meaningful or relevant, not just kind of settled science or settled engineering or a long list of skills in math. So, with that being said, that's where I'm really thinking we need to start thinking about is looking at how we can change the learning experience K through 16 to help make them more meaningful, coherent, and equitable. And so I wanted to spend a second just to tell you a little bit about what we're doing at UT Austin to make this happen. So one of the things that we have been doing here in the College of Ed is spending a lot of time creating, testing, and disseminating what we're calling high quality instructional materials that can be used all the way from kindergarten all the way through college courses, right? So we can start thinking about how we can redesign lecture courses or lab courses at the college level. What should grades 3 through 5 look like? How can we design these new experiences that are really focusing on making them more meaningful, coherent, and equitable? And what we do is we develop hypotheses about these, we generate materials, we then test them, and then the things that work, then we disseminate and get them out to teachers. And these are some of the books that I have done to get out to teachers across the nation as well as the state to get them really thinking about how can I make a change in our classrooms. Now, all of these instructional materials that we're doing, they kind of have these key features. And one is we really believe that to help people learn, we need to develop and create materials, not just by gut feeling, but really using research developed instructional models. So we spend a lot of time thinking about how do we um, sequence activities, how do we provide experiences that lead to questions, give the kids the support their needs. So what we've been doing with like in this project is building it around this STEM design challenge model where kids are introduced to a problem that they is meaningful to them, and then they identify kind of a solution to a problem of these parameters around that, and they develop models and they identify gaps in their understanding, and then we feed them the ideas they need from science or mathematics or engineering to solve that problem when they feel like they have a need to do it. So it brings up the coherence. Then they generate solutions, they evaluate those, then they go to prototype, they build, they refine, test them again. Then they get practice sharing these ideas. Okay, this is why this works. This is how I know. We critique each other's to look at the best solution. Then we reflect back on the experience. What do we learn about the content? What do we learn about concepts? What do we need to remember moving forward? And then getting used to communicating these ideas. Here's our report. We teach them how to peer review all of these pieces. So by focusing on the practices and the ideas of the disciplines, we're able to get kids a more authentic view of what happens in these STEM or STEM related careers so they can get a better sense of what this looks like and develop the skills and mindsets they need to be able to be successful at it. The second big thing we do is this: we really frame everything we do around authentic problems and actual phenomena to create a need. So instead of focusing on, hey, here's the objective of the lesson, or by the end of this lesson, you're going to know this, what we're really focused on is creating reasons for people to explore and learn something. For example, an elementary school lesson might begin with this phenomenon by showing this video. So you right at the beginning, hey, I want to show you something. Take a look at this. Kids, wow, how's that do that? And we have them hooked, right? Of okay, let's start talking about energy systems, models. Can we build a better one of these? Can we design solutions to various problems, right? But it's being driven by something that they see that's meaningful or interesting to them. Another example for thinking about that in math is we can show a news article about an election. So here's one that we set for thinking about unit rates in mathematics.
For in-person voting, other states around the country have already started, and the response is strong. In Georgia, people have come out in force to cast their ballot despite the wait times.
Day one of early voting in Metro Atlanta meant a long day with long lines. This was the scene at South DeKalb Mall. In Fulton County, there were technical problems in Fairburn. They got one good job to do in the county elections office is to make sure early polling votes is working, and they are not accomplishing that at all right now. Over in Gwinnett County,
so could you imagine a math lesson where students are introduced to this at the very beginning of the lesson of this issue of long lines and how can we use mathematics to make sure that this doesn't happen again, right? And exploring all of the ideas around that instead of just being given an objective to follow. Or how about an example like this for engineering where we just had another spat of cold weather, but thinking about, okay, hey, if we are into engineering, we can also make our community help our community a little bit more. So here's another example of that.
Cold nights ahead, efforts now underway to help the homeless shelter against this cold.
Yeah, Erica Zuko joins us now with what's being done, Erica, and how everyone can help.
Yeah, Barry and Sarah, there are some ways that people can help. If you see how cold it is outside, you know how important it is that people have that winter clothing ready. And we've been outside this morning for probably about half an hour or so, and it is pretty chilly. Luckily, not feeling any of that precipitation downtown this morning, and we see that the plants are covered up. Not as many people as we normally see out in the morning, but still have seen a few people out in these cold temperatures. So we know that the city's Department of Human Services is
so you organize, instead of teaching about engineering by having them build the largest straw tower you can, or build a contraption that keeps an egg from breaking when you throw it off the side of a building, we frame it around how do we help people stay warm? So in this case, they build hand warmers that they can use using chemical reactions that they can give out to people during a cold snap that we have like this. So it puts the meaningfulness of what they're doing and how you can use STEM disciplines to help make the world a better place right at the forefront. Third thing is we want to make these experiences so students have opportunities to learn the ideas and practice along with their own ideas instead of just memorizing facts, terms, and procedures. One of the things that we hear constantly about STEM learning experience is there's nothing but more than a bunch of vocabulary to memorize, a bunch of procedures that we're supposed to follow that we don't know why we're following this. But instead of focusing on that, giving them opportunity, how the different ideas that we can pull from and these practices that we can engage in to make to solve problems is a really powerful way to get students thinking and learning and seeing value in the discipline. And then the fourth key is really thinking about how we sequence these activities. So by putting these phenomena in front, we create a need for them to learn instead of having it as last, where it's an example of, hey, if you've learn these skills someday, you'll be able to use them in this situation. Here's an example of how somebody else did that. So by putting it at the front, we're able to sequence based on what students need to know to be able to solve their questions, answer their questions, and solve problems that are meaningful to them. And then last, this kind of approach really turns a classroom into a community of knowers and doers. So instead of reading about others doing science or engineering or watching documentaries of people that are older than them or further along in their career, they get an opportunity to actually do it, right? So it gives them an opportunity to feel like their ideas and participation are valued while they're actually engaging in the kinds of activities that they will do later on, not because it's going to happen 10 years from now, but right now. The last thing I want to kind of think about too is so that's kind of things that we're doing here at UT, but I always think it's important to talk about what we can do as a community. And as the group of Texas X's, there's definitely some things that we can do as a community to help make STEM learning experiences more meaningful, coherent, and equitable for students as well. So I've got a couple of recommendations on that before I take some questions. First, I think is really what we need to do through elections or talking to the State Board of Education. They're the group that's responsible for adopting our standards and deciding what kids need to know and be able to do. I think we as a community really need to start focusing on our standards, which are called the TEKS, the Texas Essential Knowledge and Skills, that emphasize thinking way more than they emphasize memorization. For example, right now, this is what our standards look like in fifth grade in biology, right? So things like illustrate how much matter is made up of particles and that are too small. That's a fact, right? Or tell me the chemical equation for photosynthesis or cellular respiration. Facts, right? These are not ever using these ideas or practices to figure things out. Same thing with math. Fifth grade, identify a prime and composite number. Describe, or in algebra, describe the relationship between linear factors and quadratic expressions and the zeros. Seems like something they'll always be using. Skills out of context, right? So how do we develop standards that actually call for students to think and use these ideas and practices in meaningful ways so they get practice doing that before they enter a career and decide that's not for them? Second thing we can do is we can push the State Board of Education to adopt review criteria that really focuses on the nature of the learning experiences of instructional materials versus how many TEKS they cover. So the State Board of Education is one of their primary jobs is not only development of the standards that are set the curriculum for the state, but also how instructional materials are reviewed and then recommended for schools to use. Right now, their criteria really focus on just how many of the TEKS are covered, 90%, 95, 100%, and really do very little to focus on the nature of the learning experience. So you can have materials that are very much focused on memorization, lecture, all of these kinds of things, and they really don't focus on how to make things more meaningful, coherent, or equitable for students. We can make that change with a little thing. We can also start pushing on the Texas legislature and the school board to create and use new school accountability measures. So instead of just saying how many students passed a test on these TEKS, we can start asking them to say, how well are you providing opportunities for all students, right? Are you making sure all students are able to get into courses? Are you offering that? Are you providing the support they all need to be successful? Are you ensuring that they feel like they belong or they feel like they are an outsider or unwelcome? These are the kinds of things that will help people want to stay into these fields. And these are kind of the things that we can really focus on in terms of our accountability measure. And then finally, it all comes down to funding, right? So if we make these recommendations about instructional materials, schools need the money to be able to adopt them. They also need to be able to, we also need to do a better job of funding our preparation programs so teachers learn how to teach in this way and support students and use these materials. And we also need more funding for continued professional learning opportunities for current teachers, right? So instead of just giving them new mandates or requirements or things they have to do, let's find ways to help them learn about these new innovations like what we're doing here at UT, so they can learn how to use them and see why they're so valuable. Um, so those are kind of the big things, thinking about how we can move toward a STEM education system that matters. Really the kind of outlining what we're doing here at UT to develop instructional materials and thinking about the learning experiences and what they need to look like, and also starting to think about what we can do as a community to help make this kind of vision a reality. So hopefully this was interesting to y'all. Got a few minutes for some questions now, if anyone would like to ask.
Yeah, we do have a couple coming in. I am going to just read these out and then you can answer them how you do. Does that work for you,
Sure.
Dr. Sampson? Okay. So first question, this curriculum sounds like work that a nonprofit I work for does with actual companies. I like how this has been translated over to the classroom to make it more widespread. So the question really is the curriculum widely available?
Yeah, well, yes and no, right? So one of the things that we're very good at universities is, well, in the past we were able to get funding from like NSF and other agencies like the Institute of Educational Sciences to spend the time developing these, right? So developing curriculum can kind of go of one of two ways. One, you can have a group get together and kind of use best practice recommendations. Those are often called research-based curriculum, right? So you pull ideas from the literature and say, the literature says this is a good thing to do, so we added this into our curriculum. What we like to do is take a much different approach, is where we develop it through research. So we test hypotheses, we develop materials that are based around those hypotheses. We actually measure how much students are learning, and if they're not, we change it, right? So instead of putting the thing of like, this should work, to does it and how can we refine? Now, the reason I bring that up is that's what we're able to fund at universities. So what we need is more and innovative ways to get ideas out to more teachers, right? Education by and large tends to be a very isolating profession, right? Because you spend all day with your students and then you've got grading and then you've got all these other things to do. So that's why you need more opportunities for professional learning and funding so they can get their hands on this. So I'd like to see much more of, like nonprofit partnerships, other business partnerships working together than to help with the dissemination of these. And it's not just putting it in people's hands, but really helping people learn how to use those, because it becomes a fundamental shift in how we think about teaching, right? It's not just sharing information or presenting information and giving homework assignments, but it's really creating a community and an experience where ideas and practices and sense making matter.
Okay. There's another question. It's about specific programs at UT. Could you talk about any specific STEM programs that are available for the lower schools, particularly 1 through 6th grade?
Yeah, so that one there, I was talking about there, that program's called Argument-Driven Inquiry. I'll give you some information about that. UT has long been a institution that's very interested in focusing on K-12 educational spaces. So one of the things that has been developed at UT is the on-ramps program, which is an alternative to kind of the AP, which gives students opportunities in high school to do college level work and get college credit at the same time. So they're able to move right into a Texas institution and start moving in through that. And the idea behind that is those learning experiences look more like the disciplines, like I'm talking about, that are more meaningful and coherent, versus the laundry list of facts that you need to remember for AP. On the younger grades, people in the College of Education are all working on this. It depends on subjects. So my team focuses specifically on STEM. That's kind of the project. That's the things we're working on. There's also other ones called open science education or just science specific that we have faculty involved with. The big thing is, like I said before, it's not so much the building of these new materials. It's how do we get them out to folks, right? In ways that they know about them and then have opportunities to learn how to use them in ways that are effective and meaningful and help kids learn and fall in love with those things. So that if you contact me, I'll give you my contact information here at the end. I can send you anything you want in terms about specific programs at different grades. We've got lots of great things being developed here at UT.
Perfect. Here's another one that's kind of along the same lines, but how has this research and the proposal for how we teach impacted the way that you are specifically educating educators?
Oh,
So how has it changed the curriculum for educators?
that's fantastic. Actually, I just came from a class this morning. So I got my morning elementary science methods just finished about 15 minutes before we started here at noon. So yeah, what we're trying to do more for teacher education. So I teach both in the elementary program, so the K-6 space, and I also teach in the U Teach program, which is 6 through 12, right? And in both of these programs, we're really focusing on the use of the materials that we are developing and bringing those into our classes and giving our teachers more opportunities to rehearse using them. And what I mean by that is instead of having teachers try to come up with lessons from scratch when they're novices, right, which end up being lessons that look a lot like kind of traditional ways of teaching, right? So I learned about chemistry by balancing equations, right? And I've got a great lecture for that, or here's a video on that. And having teachers build lessons from scratch. What we do instead is we provide them with these materials that have the lessons and units already laid out that are phenomenon centered, focus on sense making and practice. And then what we do in class and out in the field is we give them these resources and have them practice using them, right? So then when they start using them, they can see how powerful they are. They can get used to what kind of questions I need to ask. How do I facilitate? What happens when someone gets stuck? How do I modify this? They can focus on all the important parts of the interactions that happen between students, ideas, and them. And then as they get used to this, that becomes a vision of what we're hoping to do and what we can do in our school system. And then you can start learning how to build these things yourself, right? And then from there, so it's putting a different spin on instead of building first, we learn how to teach really, really in powerful ways. And then we get good at building things to help support that way of teaching.
Gotcha. There's a couple of questions out here about AI and specifically, how do you think access to AI tools today by students is affecting the STEM pipeline, if at all? You
Oh,
know,
actually, that's really interesting. I was just asked to give a talk a couple weeks ago about AI and computer science, right? And one of the things to think about is how the nature of AI has really changed. So we've had AI, if you define it as just a machine able to do kind of human-like thinking, we've had that for a long time. So anytime we have Netflix recommendations on our apps or things that automatically do workflows, or even cars that do adaptive cruise control, all of that's kind of AI. What's really flipped now is the generative AI. And what that means by that is the past versions of AI, we had to predict things. So it was always responsive. Like you see this, do this, right? This trigger happens, then do that. With the generative AI, now it's become we can have AI create things that have never been there before. And that's really changing a lot of these fields in terms, especially in terms of computer science. And it'll be interesting how the job market goes. One of the reasons we had such a push in computer science I was talking about before was the problem is of you get a degree, instantaneous job, you're making more than anybody else, just learning how to code. Well, now we have the ability to have things code for us, right? So the question now becomes, as people are moving into computer science and other STEM fields where they have this tool, it becomes what becomes your value, right? What makes you unique? What do you bring to the table, and so to speak? How do you learn what counts as quality? How do you critique? How do you revise, right? those become the skills that are most important because we can have things generate code. The problem becomes, is it good code, right?
Right.
If you don't have to have experience coding, why do you need to learn how to? So these are the questions that we're hitting right now. So I think there's going to be a lot of changes in what's privileged in terms of not only what's in the careers, but how we better prepare those. And I think in some ways we're ahead of the game of moving to the K-16 space, really focusing on figuring things out, critiquing each other's engaging in practices, and not just plug and chug of ideas or lines of code and things like that. So it'll be interesting to see. I don't think anyone has a full answer yet. It depends on how people adapt those, but that's kind of what I'm seeing coming forward.
Okay. So in regards to STEM education across K through 12, let's talk a little bit about funding sources such as NSF and the idea of the state of Texas now that vouchers are available. Can you
Mhm.
comment on any of that that's going on?
Sure. So one of the things that we're seeing in terms of education in general in Texas is we have never done a fantastic job of funding it. So we're of the 50 states, and you can think about like per student funding is usually the metric we end up using is like how much per student is devoted by the state or from federal sources. So Texas has long been around 45th in the nation or so for funding public education. The problem that we now have with vouchers coming in and thinking about even charter schools is that we're basically slicing up the piece of the pie that we have devoted, which is not very large in terms of overall GDP of the state. We don't have a huge pie, and now we're slicing it up to also go to more and more different kinds of schools instead of really focusing on what we can do to help the schools that we have, right? One of the things I was mentioned before is the focusing on the accountability measures. We have had a long tradition here in the state of basically holding up test scores as the metric. And if you're not getting good test scores, it's up to you to solve the problem as a school, or you're shut down or taken over, or something happens to you, or we divert funds away from you and give them to somebody else that'll do the job. What we're finding is research wise, that doesn't really work, right? If anything, if education requires more support, more learning, and taking funding away from public schools is only going to exacerbate the problems that we're seeing of schools not being able to afford good instructional materials, not being able to train teachers, not being able to, even as universities, being able to provide really in-depth learning experiences for future teachers, right? So we really need to start thinking about how do we help grow and support schools and help them learn and get better versus than penalizing them or for not doing well on a test, which may or may not be the best way to really think about how we measure quality. Wouldn't we rather really know if our students, if your child's going to school, do they have an opportunity to take some great courses? Is there some great teaching there? Do they feel like that they belong? Do they want to be at school? Do they get the help that they need? These are all the questions that we really care about in education, and we don't measure any of those, right? So the short answer to your question is by diverting school from public school, diverting funding from public schools to private schools, we're not fixing any of the problems or any of the things and supporting these. And if anything, we're just going to make those problems worse in the years to come.
Right. There's another question out here, just in general, about, how do we educate the ledge to lead them to those decisions that's, STEM funding is important.
Yeah.
So there's this largely perceived, idea out there that they don't value STEM, that they don't value that. So can you comment on that?
Sure. It got me really going on these things. I mean, and that's exactly why I'm doing these kinds of talks, and I always get out there as much as I can to share, right? So
Right.
education is a very interesting field, right? So when you think about education, it's one of the only fields that we feel that people who are not experts at it can make decisions about it, right? So we often will elect folks or put people in charge of committees or policy making with very little experience when it comes to education, which seems kind of crazy to me when you think about let's say you were building a house, would you give somebody that's never built a house a contract before, right? Or would you look for someone that has the most expertise? If you're going to the hospital, would you want to have someone do surgery if it was their very first surgery on you, or somebody that's been doing it for 20 years, right? But in
Right.
education, we seem to have the opposite of like, oh, I'm outside the system. I wasn't part of this and I can fix it. Which really what we need to do is spend more time is really look at our elected officials and see who's running, who has the most experience into these, who has dove in, who has actually done research these, understand these problems that are coming up and how the best way to handle it. Because a lot of them, we can solve them if we fund them and put the right policies in place. If we don't fund them and put the wrong policies in place, they get worse, and then it becomes a, well, education's broken problem. So the thing I think is in the short term is educate yourself on who candidates are running and why and what are their initiatives and what are they thinking about and why are they doing what they're doing, and do they actually have the background to be able to do these kinds of things? So when they're sitting at a meeting deciding what every student in the state is supposed to learn in terms of standards, or what instructional materials can or cannot be used inside the classroom, it's being based on research rather than policies or rather than personal beliefs or politics.
Hmm. Okay. I'm going to go back to a couple things and then we'll finish up. This is a good question. What metrics will you use to ensure that students felt valued in their STEM opportunities, or what have you been talking about? How to measure that? How do we make sure that they feel that value, that they are connecting?
I think we need to ask them, right? So one of the things that comes through my research is we spend a lot of time asking how they feel, right? So we target different aspects of pieces, and we'll ask, do you feel like people listen to your ideas today? Do you feel like people respected what you had to say? Did you feel like you could participate without being feeling like you're going to be made fun of? We specifically ask those questions to students, right? And it's actually really easy to do on kind of an informal level. What we do, like there's a common practice in education circles of what's called bell ringers, short little questions that are asked when students come in and come out of classes. What we do for research wise is have students just fill out a couple of quick survey questions of what it is and tell us why. But you can amp that up and actually, instead of giving these statewide tests like the STAR and end of course exam, which we spend just millions of dollars on. We can also just send surveys to students and ask, hey, do you feel like you belong at your school? Did you have enough support to do what you're doing? Kids will tell us. We never ask, right?
Okay.
And
Yeah.
so I think if we start thinking about really moving our accountability systems to looking at are people do feel people feel happy? Do they have opportunity? I know my kids come home every day and tell me about all the things that are wrong with their school or their classes or what they didn't get to do. We'll learn that stuff really fast. We just have to ask, right? And then
Yeah.
if we're worried about kids performing well on standards, we can move instead of testing models, we can move to things like standards-based grading, where we're not just grading on completion of things, but how well they've achieved these standards. Those systems, there's research around that show that those things work. We just need to be willing to dump the tests that are boiling everything down to a single day's performance to really thinking about what do we value in our schools? What would we like to see? And do we know if that's happening or not? Instead of making it a black box where if they get good test scores, everything must be fine.
Okay. So I just wanted to go back to the flow chart, the
Sure.
flow chart, just real quick.
Sure.
There's a couple questions. I think that one of your ideas was that the idea that graduates of STEM degrees and majors decide they don't want to go into STEM related jobs. And then, are there specific reasons for that? So they're already graduated and
Yep.
now they're deciding not to. Is that because of their courses that
Yes.
they experienced? Okay,
Yeah.
so there is a direct
So,
correlation.
so what we're
Okay.
seeing you can think of it as back to these things, not meaningful, not I don't enjoy this. I don't feel like I belong, right? So we have this so people get tracked into these majors, right? So if you want to graduate on time, you start on along a major, right? And if you want to change that major, the further you're along, it's almost impossible to change, right? Without adding 2, 3 years to your sequence, which is even more tuition and all that. So lots of students are figuring out about halfway through, man, if this is what my courses are like, I don't want to do this as a career. I don't like any part of this. I don't like how it makes me feel. I don't like how it's rushed. I don't like like whatever the reason is. And then, but in order to graduate on time, they just finish up and then they go find a different career. That's the thing that we're seeing the most things happen right now is these experiences in their coursework. We get them in, but it's really chilly and feeling unwelcoming. So they then just tough it through and then go find something else to do.
Gotcha. Well, that is all the time we have for today. Thank you, Dr. Sampson, for
Cool.
speaking with us today. And thank you everyone who joined us. We're very excited that you came and that you listened to Dr. Sampson's wonderful talk. Our lunchtime lecture series will continue with a virtual lecture on Tuesday, February 17th. Joanne Hawley from the College of Natural Sciences will present bees, wasps, and bacteria, big discoveries by UT undergraduates. I'm looking
Very
forward to
cool.
that one. And you can register as an attendee at texasexes.org/lunchtime lectures. Thanks, everyone, and y'all have a good week.
Oh, Patricia, before you close it real quick, here's some
Okay,
ways to learn more. I just want to put this up here, and when you get the video on that, if you want to look at more about those high quality instructional materials I spoke about, you can go to that website. If you want to look at
perfect.
our current TEKS, those are right there, our review criteria. And if you want to know who's running for the Texas State Board of Education, you can go to that link right there. That's how you can learn some more. And then that's how you get a hold of me if you have any questions.
Thank you so much. Sorry about that.
No problem.
Thank you.